So, what if we had a thermostat not just for our homes, but for the entire planet? Today, we're diving into one of the most ambitious, most mind bending engineering ideas ever put on paper: a giant, intelligent mirror orbiting the Earth. Let's just start with a simple question. What if we could give planet Earth its own pair of sunglasses? And I'm not talking about some dumb shades just to block the sun. I mean a smart, adjustable pair that could precisely control the light and the heat, reaching any part of the surface. And that, right there, is the wild idea we're uncocking. All right, so here's the game plan. First, we're going to look at the climate chaos we're already dealing with. Then we'll look up, way up, for this wild solution. We'll get into the nuts and bolts of how it works, weigh the amazing potential against some very real risks, and then we'll wrap up by asking what this kind of power really means for all of us. Okay, let's start right here on the ground. The problem we're trying to solve, it's not just that things are getting warmer. It's that our climate is becoming dangerously unstable, just completely chaotic. And that instability, it creates this kind of global mess. Think about it. One part of the world is literally baking under a record heat wave, while another is getting slammed by a freak polar vortex. These extremes, they put a massive strain on everything: the food we grow, the power grids we rely on, even our solar farms. And here's the fundamental problem with all of our current solutions. They're stuck down here with us, right? We can't do anything about a solid week of cloud cover killing a solar farm's output, and we sure can't change the fact that our planet is tilted on its axis. To get around these basic facts of life on Earth, you kind of have to think beyond Earth itself. Which brings us to this incredible idea: putting a massive, controllable mirror system up in orbit. The concept is called the Earth Ring Mirror, and the most important word here isn't block. The idea isn't to create a giant shadow. No, it's to manage the sunlight with surgical precision, to gently nudge it away from a region having a heat wave, or maybe even concentrate it to give a boost to a solar farm in the dead of winter. I love this analogy. A planetary ophthalmic lens, it just nails it, doesn't it? This isn't a sledgehammer. It's a tool of incredible finesse, like a giant pair of glasses, designed to correct and fine-tune the sunlight our planet gets. So let's get one thing straight, because it's really important. This is not some sci-fi solid ring that's going to block out the stars. And it is definitely not that controversial idea of just spraying a bunch of chemicals into the atmosphere. What's being proposed here is a clean, totally optical system. Basically a swarm of small, independent reflectors all working together. Okay, so how in the world would something like this actually work? Let's get into the mechanics. So you'd have this system orbiting somewhere in low to medium Earth orbit. And I want you to picture a huge swarm of super thin, lightweight reflective panels, almost like tiny solar sails, all flying in a perfect formation. Now, they're not physically connected. It's more like a virtual chain that's coordinated by AI. This design is brilliant because it makes the whole thing incredibly resilient. If one little panel gets hit by space junk, it can just deorbit itself, and you send up a replacement, all without affecting the whole ring. And the way it operates is based on a really, really simple idea. You just change the angle of each little mirror. That's it. You angle them to bounce sunlight away from Earth, and boom, you get cooling. You angle them to focus that sunlight on one little spot, and you get concentrated energy. Or you find a sweet spot in the middle, and you can create a soft, diffused light, kind of like on a perfectly overcast day. And this is where it gets really powerful. In deflection mode, you could literally create a moving shadow to cool a city during a killer heat wave. With concentration, you could give a solar farm a massive boost on a cloudy day. And with diffusion, you could shield crops from that brutal midday sun, helping them survive a drought. So when you put all of these abilities together, what you're really talking about is a global thermostat. I mean, let's just look at the kind of impact this could have. Check this number out, it's pretty wild. To make a huge difference to the temperature on the ground, the system would only need to deflect the tiniest fraction of incoming sunlight. Just 0.1%. It just goes to show you how sensitive our climate really is and how precise a tool like this could be. And then you've got the other side of the equation, power generation. By focusing sunlight, the ring could boost a solar farm's output by 3 to 5 times. All of a sudden, solar power isn't just a daytime thing. It's a much more reliable and powerful energy source, pretty much whenever you need it. And the ripple effects? Oh, they could create this cascade of stability. More predictable sunlight means more reliable crops.
Cooling down a city takes a huge load off the power grid from everyone blasting their AC. You might even be able to subtly influence weather, maybe help stabilize monsoons or reduce evaporation from reservoirs that are drying up.
But let's be real, a project this big, this ambitious, it comes with massive risks. You have to balance all of this incredible potential with a very, very serious dose of caution. Now, the people behind this idea, they're clear that you can't build something this powerful without building in some serious guardrails. You've got space junk, right? So each panel would need shielding and the ability to safely deorbit itself. Then there's the huge political question. Who gets to control the planet's thermostat? The only real answer there is some kind of international body, like the UN. And to stop anyone from, weaponizing it, you need hard-coded limits and fail-safes built right in. And this right here, might be the single most important safety feature. Unlike ideas that involve messing with our atmosphere or our oceans, this system is totally non-invasive. And it's completely reversible. If we ever decided, you know what, this was a huge mistake, we could just switch it off. The panels would drift apart and eventually burn up, leaving no permanent scar on the planet. So, if you take a big step back, what's the long-term vision here? Well, it's about something way bigger than just climate control. It's about fundamentally changing our relationship with our own planet. This quote really gets to the heart of it. For our entire history, we've just been passive victims of the weather, of the climate. A tool like this would, for the very first time, make us active stewards of our own environment.
So when you boil it all down, the Earth ring mirror isn't just a big mirror in the sky. It's really this combination of so many different fields: optics, AI, orbital mechanics, climate science, all coming together. It could be a whole new level of what you might call planetary intelligence.
Which leaves us with one final and kind of heavy question. Is this kind of technology humanity's greatest tool for survival, or is it our most dangerous temptation? The power to control the sun is the power to secure our future, sure, but it's also the power to make unimaginable mistakes. And the answer to that question, well, that's probably going to define our next chapter.